r of x equals 3x squared minus 3x over x squared plus x minus 12. I want to go ahead and graph this equation as best as we can. First thing I usually like to do is use a correct color pen. And then once I do that, I want to rewrite it as factors. Now, a couple things. Once we write it as factors, I'm able to determine some things fairly quickly. One thing I'm able to determine is where are its solutions. And our solutions are when the factors in the numerator become 0. So I have solutions at the point 0 and at the point 1. The denominator will also tell me where I have some domain restrictions. And I have domain restrictions at the points -4 and +3. And both of those, since none of these factors canceled out when I did a reduction, both of those are vertical asymptotes. The next thing I want to discover is if there's a horizontal asymptote. What I notice is that the coefficient of the numerator equals the coefficient of the denominator. So therefore, the horizontal asymptote is going to be a horizontal line. And the line is going to be determined by the ratio of the leading coefficient and of both terms. So 3x squared over x, their coefficients are 3 over 1. So therefore, I have a horizontal asymptote at the line y equals 3. I also want to find out is anywhere on this graph, does it pass through that particular asymptote? To find that out, I want to take y equals 3, that line, and I want to evaluate the function to find out is there a place somewhere that I do cross through. So 3 equals the function 3x squared. You guys make sure I'm not making any mistakes. I got x equals 6. So what that tells me then is that where x equals 6, 1, 2, 3, 4, 5, 6, right here, that point is a solution to this graph. So there is a pass-through on this graph. So in each of my regions, region 1, region 2, and region 3, I now have enough information to give a very decent idea what this graph looks like. In region 1, I have two choices. It's going to be down on the bottom side of this asymptote or on the top side, since it doesn't pass those asymptotes. How do I know which one it goes on? Well, it's going to go up here. And the reason why is, if it were to go down here, for example, like that, I would have discovered that there would have been another x-intercept. But there was not another x-intercept. So therefore, I know the graph has to remain up in that region 1. In region 2, I can kind of think the same thing. I have an asymptote bounded on 3 sides. And I have these 2 points for it to go through. So the only way that I can create a graph that goes through these 2 points, but is also fits in, has to come from something along those lines. On the third side, well, we know it doesn't go on the bottom because, again, we did not find another x solution or next x-intercept. But however, we got this little pass-through point. What does that mean? Well, what it means is the graph will start, it will pass through that point, but once it passes through that point, it can't cross the x-axis here because there's no solutions, so it bounces back up and approaches that line asymptotically. So there's a rough guess, well not a rough guess, fairly good guess of what that graph looks like, 3x squared minus 3x over x squared plus x minus 12, by just taking it bit by bit throughout the process.